Okay, come back to question 12. Three vectors are shown in figure 341. Their magnitudes are given in arbitrary units. That means you can just use any units. So we just call it units. So B have a unit of 26.5, A is 44, and C is 31 units. That unit can be meter, centimeter, kilometer, or any other derived unit also can. Force, Newton, for example. Determine the sum of the three vector. Give the resultant in terms of components. And B, magnitude and angle with the x-axis. Okay, so first, we have to split the vector into their own component first. Okay, so we draw that vector. First one, we draw our coordinate axis. Okay. So this is our first vector, which is roughly 28. It's the longest vector here. Okay, this angle is 28.0 degree, and this is vector A, and it is 44 units. Okay, and then our vector B is here. So if we are not mistaken, let's see whether they are 90 degree or not. Minus 56 minus 28, 96. So it's slightly more than 90 degree here. So it's not 90 degree between them. So that is our B. B is the shortest vector. So our B here is 26.5 units. And this one is 56.0 degree. And our last vector is a C. It's straight down. There's your C, and it is 31.0 units. Okay, and the direction is 90 degree. Okay, from the horizontal line. So this is our X, this is our Y. So split them into their own component, into their horizontal and vertical component. So for A first, okay, I will use different color for each of their component, and the B also have a different color also, except C lah. Now for the A, this is the horizontal component. I call this one VX, and this one here is a VY, red color. Okay, VY, and then for the B, blue color. This one is a VX and slightly shorter than the other side. This one is a VY. Okay, so maybe I will use VX prime, and this one is VY prime, so that you don't get confused between which VY we are using and VX. So now the C itself is the vertical component. Okay, so we go to calculate the component for the A. So our vector A, our Vx is equal to 44 cosine 28. So at 44 cosine 28 is going to give us 38.8. Okay, 38.8 units. Okay, and it is positive, right? So that means our later we change into component format. Our Vy is 44 sine 28. So 44 sine 28, we're going to get 20.7 units. So our vector A is equal to 38.8i plus 20.7j units. Okay, and then for the B, our Vx prime is equal to 26.5 cosine 56. Okay, so I have 26.5 cosine 56. We have 14.8 units, and then our Vy prime is equal to 26.5 sine 56. So 26.5 sine 56, we get 21.96 9, so we have 22.0 units. But this one is negative, so our vector B is actually negative 14.8. Okay, I, and this one positive, the blue Vy prime is positive 22.0 J units. Okay, and then our C is downwards. Our vector C is very easy, is negative 31.0 J units. Alright, so that is our component for the vector A, B, and C as well. Okay, next one is calculate. Okay, determine the sum of the three vectors, give the resultant in terms of component. So our first one is we sum them up, A plus B plus C, but in the format of components. So we write down this 38.8i plus 20.7j, that is A, plus B is this one, negative 14.8i plus 22.0j, plus last one is negative 31.0j. Okay, so we have to sum them up, I and I, j and j. 38.8 minus 14.8, that's it for the I, so we have 24.0i, and then the j will be 20.7 plus 22 and minus 31. Okay, so we have 11.7j units. Alright, so that means this one is in the answer in the components method. Next one is we're going to change this one into the answer that we did like before in magnitude and direction. Okay, magnitude and direction. So we know that we can draw this vector actually. Okay, and that vector is this. We have 24 I and 11.7. Okay, this one is 11.7j. So if we combine, we get this. Okay, we get this. This is our vector A plus B plus C, and the angle here I will call it alpha. Okay, alpha. So I get the magnitude first. The magnitude of our vector here, A plus B plus C, is a square root of 24 square plus 11.7 square. Let's see what we get here. 24 square plus 11.7 square, and square root everything, we get this 26.7 units. Okay, 26.7 units. And after that, tangent alpha is equal to 11.7 divided by 24. So our angle will be arctangent 11.7 divided by 24. Alright, so answer is 26.0 degree. Okay, 26.0 degree. That is question 12. That one is difficult. Okay, next one will be 13. Okay, 13. So question 13, given the vector A and B as shown in the diagram 341, determine B minus A. Okay, determine A minus B without using your answer in A, then compare result and see if they are opposite. Alright, so we're going to hijack the value for the component. Okay, so we already know that our A is equal to 38.8i plus 20.7j, and our B is negative 14.8i plus 22.0j, and our C is negative 31.0j. Alright, so I'm going to use this value to solve our question in number 13. Okay, first one is find the value b minus a. Okay, b minus a, there'll be this one minus this, so we show the value directly here. This component minus that component, you just simply actually sum them up. 14.8 plus 38.8, so you have 53.6, negative 53.6i, and then this one minus that one, you have 1.3, right? 22 minus 20.7, 1.3. Okay, we have a positive 1.3 j units. Okay, 1.3 j units. Okay, next one, b, a minus b. Okay, a minus b, so a minus b, answer will be positive 53.6i, and this one you minus that, you got negative 1.3 j units. Okay, without using your answer in A, so you calculate based on what you are given. And the next one is then compare your results and see if they are opposite. Of course they are opposite. If you want to draw, you can see what happened to them. Okay, so first we draw on the same axis. We draw our first vector for b minus a will be this one, negative 53.6, so I use 5.6. okay, 5.6 here, so about this one. Okay, about this one, so that one is the negative 53.6i, and then positive 1.3, so since it's very small, I'll use 3. Okay, I'll use 3 here. This is 1.3 j, so combine them, you get this vector. Okay, this vector is your vector b minus a. Okay, then the blue color is 53.6, so that one will be, I will be using the same one here. Okay, 5.6 here, the blue one, so this one is the blue one, this one is the red one. Okay, so the blue one positive, so this one is positive 53.6i, and then you have a negative, so negative, remember I used 3, right? So that one is negative 1.3 j, and then we combine both of them. See the direction? Okay, and this one is a vector of a minus b. They form a straight line, but they are opposite, same magnitude but opposite. Okay, it's proven that they are opposite. Okay, so that one is question number 13. Next, question number 14. Okay, 14 asks for the vector given in 341, again the same, determines, okay, he just simply determine, find value only, find a minus b plus c. Okay, we're going to use the vector again here. Okay, I'm going to use this vector. Okay, so a will be 38.8i plus 20.7j, minus b is negative 14.8i plus 22.1j, and then plus c, negative 31.0J. Okay, see what we have here. So this one is 38.8 minus become plus 14.8. Okay, we get 53.6I. And then a J 20.7 minus 22 and then minus 31. Okay, so I got negative 32.3J. That's it. Answer didn't say anything about magnitude and direction, so we just leave it like that. Okay, so that is A. And then B. B is A plus B minus C. Well, same thing here. We can actually use this one, but it's better just write down 38.8I plus 20.7J and then plus, okay, plus B, negative 14.8I plus 20.0J, 22.0J, sorry, and then minus negative 31.0J, that's a C. Okay, now is 38.8 minus 14.8. So we have 24I. And then next one is 20.7 plus 22 and then plus 31. Well, there's a big vector here. Plus 73.7J. Okay? Units. Next one, C is C minus A minus B. Okay, C minus A minus B. So that one will be C in front. Negative 31.0J and then minus A, 38.8I, 20.7J and then minus again, negative 14.8I and plus 20.0J. Okay, we have minus 31. Oh, sorry, that one is J. We look for I first. That is a minus 38.8 and then plus 14.8. So we have negative 24I and negative 24I. And next one is this one. Negative 31 minus 20.7 and then minus 22, so it should be the same answer like before. So I have negative 73.7J units. Okay, so that is question number 14, totally using IJK method. Okay, IJK methods. Alright, next one, 15. So 15, for the vector shown, determine A, B minus 2A. Well, that one is a vector multiplied by numbers. Okay, vector multiplied by numbers. So we have B. Our B is this one. Negative 14.8I plus 22.0J and then minus 2 times of A. I plus 20.7J. Okay, so just remember to multiply by the number 2 when it comes to this one. So here we have negative 14.8. Okay, and then minus 2 multiplied by 38.8. Okay, so we have negative 92.4I. And the next one is 22 minus 2 times 20.7. Okay, we have negative 19.4J units. That's the first one. Next one, B. B is 2A minus 3B and plus 2C. Okay, so that one is torturing. Okay, we have 2A 2 times A, 38.8 I plus 20.7 J minus 3B, negative 14.8 I, and then plus 22.0 J. And last one is plus 2C. Okay. Well, next. Okay, this one need a lot of calculator work here. Okay, first one is 2 times 38.8. Okay, these two multiply, it will get positive. So sum up 3 times 14.8. That's it for the I. Okay, 122. Okay, 122. 122I. Next one is this. J. 2 times 20.7 minus this one now. This one had to minus 3 times 22, and then also minus 2 times 31. Okay, so you have this minus 86.6 J units. That's it for question number 15. Okay. Next one, 16. 16. The summit of a mountain. Well, this one is an applied question. The summit of a mountain, 2,450 meters above base camp, is measured on a map to be 4,580 meters horizontally from the camp in a direction 32.4 west of north. Okay. What are the components of the displacement vector from camp to the summit, and what is its magnitude? Choose the x to be east, y to be north, and z is up. Well, this one is almost like 3 dimension. Okay, tell you what, 3 dimension, good news. Okay, good luck.